Okay, so the topic for today is going to be solving radical equations. But before we start solving radical equations, let's go back and do a little bit of review with simplifying some radicals. I have 3 review questions up here at the top. I'll do the first one with you, and then I'm going to let you go ahead and try a couple on your own. So if I have number 1, the square root of 49, a to the 8th, b to the 2nd. I'm thinking the square root of 49, I'm going to say is 7. A to the 8th, remember our index here is 2. And I could rewrite that as a fraction exponent. I would have a to the 8/4, b to the 2/2. That just makes it a little easier to see how we're going to solve that. 7, a 8/4 would be 2, because 8 divided by 4 is 2, and b to the 1st. Okay, so why don't you take a second and do the other 2 on your own. Check with the answers in just a second. So go ahead and pause the video and do the 2 on your own, and then check back and see if you agree. If you have any questions, please raise your hand and ask, or let me know. Okay, so go ahead and take a look and see if you agree with what I have. If you do not, please ask and let me know, and I would be more than happy to help you out. All right, let's go ahead and start solving radical equations. There's a couple of things that you need to know. Number 1, in order to solve a radical equation, if the equation is taking the square root of something, so to undo the square root of a number, you would square both sides. And if you square the square root of x, you just get x. And to undo, say we had the cube root of something, to undo that, you would cube both sides, and the cube root of x cubed is just x. So that's the idea that we're going to be using here. And when you go to undo that square root or cube root or whatever it happens to be, you have to make sure that the radical is alone first. So you just need to make sure before you do that inverse operation, like squaring a square root or cubing a cube root, that you have it isolated. The second thing is there may be extraneous solutions, so we want to always check that. And what that means is when you go and check your answers, if you end up with something when you check that says the square root of x equals a negative number, say -5 or something like that, you can't have that. Okay, that's what we cannot have. So when we take the square root of a real number, we're looking for the principal or the positive the root of it. Therefore, you always want to check to make sure if any answer that you get is an extraneous solution or not. Okay, so, and checking on these is pretty easy. So let's look at the first one. I have 2 times the square root of x plus 1 equals 14. Well, fact 1 was I needed to get my square root by itself first. So I'm going to go ahead and divide 2 on both sides. And I just have the square root of x plus 1 equals 7. To get rid of that square root, I just square both sides. And by squaring a square root, all that does is get rid of our radical symbol. So it's x plus 1 equals 49. If I subtract 1 from both sides, I get x equals 48. Okay. When we go to check that, we just want to do a quick check. 2 times the square root of 48 plus 1 equals 14. 48 plus 1 is 49. 2 times 7 is 14. So we're good. Okay. Okay, on this next one, it's a cube root, so just keep that in mind. And I have 6 plus the cube root of y minus 4 equals 9. I need to get that cube root. I need to get this guy all by himself first. So I'm going to go ahead and subtract 6 from both sides. And I would have the cube root of y minus 4 equals 3. To undo a cube root, I'm just going to cube both sides. All that does is gets rid of my root, and so I'm going to have y minus 4 over here. 3 to the 3rd power is 3 times 3 times 3, which is 27. It is not 9. So then when I add 4 to both sides, I get y equals 31. A quick check of that, I would have 6 plus the cube root of 31 minus 4 is 27 equals 9. So I'd have 6 plus, well, the cube root of 27 is 3, and 6 plus 3 equals 9, so we're good. Okay. On number 3, you can kind of think about it two different ways. I have 3x minus 1 to the 1/5 equals 2. One way you can think about it is to get rid of that 1/5. I can take the 5th power to both sides, because inside outside here I would multiply, and I would have 5 times 1/5 is 1, so that would get rid of that fraction exponent. So I would just be left with 3x minus 1 equals 2 to the 5th, which is 32. The other way that you can think about it, if you don't like the fraction exponents, is you can rewrite it as a radical, where you would have the 5th root of 3x minus 1 equals 2. And then you're just going to take the 5th root, or take both sides to the 5th power, excuse me, and you'd end up with the same thing. 3x minus 1 equals 32. So I'm going to go ahead and finish this out. If I add 1 to both sides, 3x equals 32, x equals 11. If I put 11 back in to check that everything works out, 3 times 11 minus 1 to the 1/5 power equals 2. 33 minus 1 is 32. And the 5th root of 32 is 2, so it does go ahead and check out. All right, moving on here. This number 4 is a little bit different. If you notice, it's got a binomial here on the right-hand side. It's x minus 2. Our radical is already by itself. Okay, so we're all good there. So to get rid of that square root, I need to square both sides. And I'm left with x plus 18 over here. Now keep in mind, x minus 2 squared, okay, if I have a little thought bubble down here, x minus 2 squared is x minus 2 times x minus 2. You have to FOIL it out, multiply the whole thing out. It is not x squared minus 4. You don't just distribute that squared to everything on the inside. You need to actually multiply it out and get x squared minus 2x plus 4. And you get x squared minus 4x plus 4. So on this side we'd have x squared minus 4x plus 4 after we multiplied it all out. And since it's a quadratic, we need to get it set equal to 0. So I'm going to subtract x from both sides. I'm going to subtract 18 from both sides. And I have 0 equals x squared minus 5x minus 14. To factor that, if you're still struggling with the quick factoring of things, I can think what times what equals negative 14, and what plus what equals negative 5. 7 and 2 will get me 14. Negative 7 and positive 2 will get me negative 14, and it will also get me negative 5. So I'd have x minus 7 and x plus 2, which when I set each of those equal to 0, I'm going to get that x equals 7, and I'm going to get that x equals negative 2. Okay, so this is one we need to be careful with when we check for extraneous solutions. So I have x equals 7, and I have x equals negative 2. So I have two solutions. When I put it back into my equation, to check it, the square root of 7 plus 18 equals 7 minus 2. The square root of 25 equals 5. That's true. If I put negative 2 in, I get the square root of negative 2 plus 18 equals negative 2 minus 2. The square root of 16 equals negative 4. Now if you remember, back up here, fact number 2, when we have a square root, it doesn't have to be a square root of x, a square root of a number, we want the positive principal square root. In this case, we are taking the square root and getting a negative number, so that x equals negative 2 is going to be an extraneous solution. So our only solution in this case is going to be x equals 7. Okay, so on these last two here, okay, I have the square root of y plus 2 and the square root of 2y plus 5. I'm going to go ahead and square both sides. When I square the square root of y plus 2, I get y plus 2 equals 2y plus 5. If I subtract, I solve my equation, I'm going to get that negative 3 equals y. So let's go ahead and plug that back in and make sure that it works. If I check, I'm going to say that the square root of negative 3 plus 2 equals the square root of negative 3 times 2 plus 5. And I get the square root of negative 1 equals the square root of negative 1, which means we can have imaginary solutions. So we can say that square root of negative 1 does equal the square root of negative 1. And so we'd have negative 3 equals y is our solution. Okay. On number 6, again, we have the square root of m plus 23 and 2 times the square root of m plus 11. If I square both sides, I get m plus 23. And you have to be careful here because you have 2 squared also, so you'd have 4 times m plus 11. Because 2 squared is 4, and then the square root of m plus 11 is just m plus 11. So I'd have m plus 23 equals 4m plus 44. And when I solve for m, I get m equals negative 7. Okay, so when I go back and put those in, I get the square root of negative 7 plus 23 equals 2 times the square root of negative 7 plus 11. And I get the square root of 16 equals 2 times the square root of 4, which is 4, equals 2 times 2, which is 4. So it checks when we're done. Okay. Okay, one last thing. There may be instances where not only is there, like on question number 4, one extraneous solution out of 2, but there's also instances where you will have no solution. So for instance, if you had, say, the square root of x, that will keep it a nice simple problem, plus 5 equals 2. So I need to subtract 5 from both sides, and I would get the square root of x equals negative 3. Going back to rule number 2 up at the top of the screen, we want the positive principal solution, which means if we have the square root of a number equals a negative, that means that that is not a solution. And in this case, this problem would have no solution because the only answer we got was an answer that doesn't work. Okay, so go ahead. There's some problems in Class Kick that you need to finish up. Good luck and have a great day.